So the type of vector analysis question we're going to go over today are what we call boat questions. Okay? Now, mathematically, they're actually quite a bit easier than the vector component ones you were doing because they're really just perpendicular vectors. Like you're not going to have any like crazy angles and a ton of trig to do. You might have like one trig calculation to do. But it's important to analyze them from a standpoint of in these situations, it's not one thing happens and then the other. They're actually happening at the same time. But if I watch it, it looks like the result of one happening and then the other, right? So give you kind of an example here. Boat questions are if I am on one shore and I'm trying to get to the other shore. There's really two scenarios. I want to end up straight across the river from where I am, okay? If you want to end up straight across a river that is flowing perpendicular to you, okay? Do you row straight across? No, because then you'll end up downstream, right? Okay, so if you want to end up straight across, you've got to have a heading. You've got to have a direction that you point the boat, and then you row as hard as you can. And the end result of that will be that the current pushes you back to a vector that is straight across. Okay? Pilots have to use this all the time when they're correcting for wind. Okay, so if I'm trying to fly from Calgary to New York, if I've got a south wind that's blowing across my flight path, I've got to turn into it a little bit. Otherwise, I'm not going to end up in New York. I'll wind up in, I don't know, Mississauga or something. Okay, not where I want to go because the wind will push me off course. I have to account for that. Okay. The second kind of situation is if I don't care about ending up straight across. I just row in that direction. If I just row straight across, where am I going to end up?
Downstream.
Downstream. The current will just push me down there, okay? So depending on how fast the river is and how fast I can row, that could be a very short distance or it could be a very long distance. It also depends on how wide the river is, okay? All of these things can kind of affect it. The key here is that even though both your rowing and whatever the river is doing are happening at the same time, we still draw them tail to head. Okay? All vector quantities are added that way, even if they're actually happening at the same time. All right, so if you haven't done so already, okay, I want you to write down what's on the board here, boat question. So you're going to have a couple of examples, one of what we call rowing across and one of going across. And there's rowing across and going across. And where you end up is different in each one. Okay, so I'll give you a few minutes to write that one down. I'll scroll it up in a second. Okay, so this question starts out with a person rows a boat directly across. So you might want to add to this boat question example that this is a rowing across question. Okay, because as I said, there's rowing across and there's going across. Okay? By rowing across, you don't go straight across, right? You end up downstream if you row across. Okay? So we get kind of information that we're familiar with. We get distances. We get different velocity vectors. Okay, in this question. So an important thing to start out with is a diagram. Okay, so what I usually do is I just kind of roughly, maybe. All right, so what I usually do is I start just kind of by drawing a river. Okay, just do this. My river. Okay, here's my river. Okay, and here's the things I know. Okay, the river is 200 meters wide. Okay, so I know that. I know that the person, when they get to the other side, will have traveled 200 meters across. Okay, the other thing that I know is that this person is really powerful, because they're rowing this boat at 3.5 meters per second. That's fast. Okay, so it's like an Olympic rowing person. Okay, so 3.5 meters per second. Now, I know that that is directed straight across the river because the question told me that. Okay, I know this line here is 3.5 meters per second. But if you've ever been in a boat or swam in a river, you know that if I point myself that way, I don't go that way because the river's current is going to push me this way. And it says that that is 1.2 meters per second to the east. Okay, so I've drawn this like I did one and then the other, but they're actually happening at the same time. Okay, so when the question says, what is the resultant velocity, they want to know that line. In other words, if I had a drone up above the river while this is going on, what would the drone see? The drone would see a boat traveling along the red line, because that's what it would do. Okay? Its motion would be the result of the rowing and the current, and all the drone would see is a boat moving diagonally downstream / across the river. Okay? Now, how hard would it be to calculate the magnitude and direction of that velocity? Not very hard. These are perpendicular vectors. These were like the second kind we went over. Okay, I already have the two sides of that triangle. Okay, so all I have to do is calculate this side. So that'll just be a Pythagorean theorem calculation. 1.2 squared plus 3.5 squared. Start the calculator. Okay, and if I want to find the vector, okay, just a trig calculation, right? So that theta would be tan to the -1 of 1.2 divided by 3.5, and that would give me the direction that I'd be going. Okay, so let's do the magnitude first. 1.2 squared plus 3.5 squared. All right, so the resultant velocity of the boat is going to be 3.7 meters per second. So that's this line. Okay, and this line points, okay, or their resultant velocity points (19 degrees east of north). Okay, that part pretty easy. Right? I mean, it's just Pythagorean theorem and a little bit of trig. Okay? Here's where they're a little bit different. There's usually a follow-up question after they ask about the resultant velocity, because we haven't used this number yet, the 200 meters across. Okay? They will often ask just what this one did. How far downstream will they be when they reach the opposite shore? So if I went straight across, I would end up here. But because there's a current, okay, I'm going to end up down here somewhere. Okay? This is where it goes back to being now a V equals D over T question. Mathematically very easy as long as we figure out what things we need. Okay? So I know that the whole time the boat is going across, they're also going downstream at 1.2 meters per second. Every second they're in the river, 1.2 meters downstream. So if I want to find this distance, I need to know how long it takes to get across. Would you agree? Can I find that? Okay, here's the trick with these questions. Which one of these speeds do I use with that to figure out how long it takes to get across? Do I use the 3.7, the 3.5, or the 1.2 to calculate how long it takes to go across the river? Well, the 1.2 points, I'm going to use the 1.2. I will use it, but I'm not going to use it yet. Okay, I know it's 200 meters across. How fast am I going across?
3.5 meters per second.
3.5. Okay, this is the whole point of boat questions is to illustrate this. If I'm going to use this number, which points straight across, I can only use other numbers that also point straight across. Okay, I can't use a number that points 19 degrees east of north to figure out how long it takes me to go north. Okay, they're not pointing the same way. So if I want to do calculations using v equals d over t or an acceleration formula, okay, I've got to make sure that my vectors are at the very least positive and negative, but they can't be crooked. Okay, I can't figure out how long it takes to go south by going north. Okay, does that sort of make sense? All right. So if I know v is 3.5 meters per second across, and I know it's 200 meters across, can I figure out how long it takes to get across? Is that also how long I'm going downstream? Because they're happening at the same time for the same amount of time. The other reason we do this is also how projectile motion works. When you throw an object into the air, it moves horizontally and vertically at the same time for the same amount of time. So both questions kind of get our feet wet in motion that occurs concurrently. Okay? All right, so I can find time by going 200 meters divided by 3.5 meters per second. Okay, it's going to take this person just under a minute to get across the river, rowing at that speed. Okay, so 57 seconds. The entire 57 seconds, that person is also moving downstream at 1.2 meters per second. So the time is shared by all dimensions of the movement. Because once you get to the other side, you're not doing either one anymore, right? You stop going downstream, you stop going across the stream, you ram the boat right into the other shore and it stops. Okay, and then both parts of the motion are over. Okay, so now that I know what V downstream is, and I know how long V downstream happens for, I can figure out how far downstream I'll end up. I just have to multiply how fast I'm going downstream by how long I'm going downstream. Okay, so they'll end up 69 meters downstream of their starting point. Okay, everybody with me there? Okay, so getting your head around how these questions works is probably the hardest part. The individual calculations within are pretty easy. Okay, you have to do Pythagoras, you got to do a little trig, you got to do v equals d over t. Okay, there's nothing that's going to mathematically tax your ability in these questions. It's context. I don't know if you guys remember this, but I've said repeatedly that you're going to get more and more of these story-based questions, context-based questions, okay, that you have to interpret to figure out. Okay? Does everyone have all the stuff down for that? Now, there's a second type of boat question. Okay? This is a going across or ending up straight across question. Okay? The first one was a rowing across. We don't end up straight across in a rowing across. Okay? This is a going across question. Okay? So I'll give you a minute here to write that one down. Make sure you label it as a going across question. So in a going across question, here's how this is kind of different. Start out the same. We still want to draw a river. Okay? But now, if we're going to end up with our resultant looking like this, okay, that means if the current is flowing from left to right, which it is, then I need to row slightly upstream so that I can end up being pushed back to straight across. Okay, so I would have my rowing speed actually being the hypotenuse this time. Okay, most of the stuff we do with vectors, your resultant is the hypotenuse, but in this case, it's not. Your resultant actually ends up being a little shorter, okay, because you're combining two things that are working against each other. Okay, so the question wants to know how long it's going to take to get across. So we're looking for time. Okay. They also tell us that the person can row at 2.5 meters per second. Okay, that's how fast I can row. Is it how fast I end up rowing? No, if I row into the current, this is how fast I end up rowing, the red line. Okay, that doesn't mean I don't still do this part. Okay, I still go as hard as I can. This is still 2.5 meters per second. But if a drone was watching me, that's not what it would see. It would see me struggling straight across the river. Okay, because this current, which they also tell me, okay, is 1.8 meters per second. Okay, and the river is 50 meters wide. Okay. Okay, so if the river's 50 meters wide, and I want to figure out how long it takes me to cross the river, which side of this triangle do I need? I need the red line. Okay, this is straight across the river. This is straight across the river. I can't use this. I don't end up doing this. Okay, this doesn't point straight across the river, so I can't use it to figure that out. Try it. Is it 500? 50, no, sorry, 50 points. It's a really small decimal. Yeah, sorry, really small. Okay, so it's 50 meters across. Can I figure out what this side is? Right, pretty easily, right? I mean, it's Pythagoras, but it's backwards. I have the hypotenuse. Okay, so we would go like, sure, b squared equals the square root of 2.5 squared minus 1.8 squared. Right, I could do that. The other thing I could do is they also want to know this. What does their heading need to be? Okay, heading is what direction are you pointing the boat? Okay, that would be this line or this angle here. If I had that angle, I could use trig to get the red line. I'd get the same number either way. Okay, it doesn't really matter which way you do it. Let's get the heading first, just because that's what they asked for first. Okay, I want to get theta. I have the opposite side and the hypotenuse. Which trig function should I use? Sine. Yeah, sine is opposite over hypotenuse, right? Okay, so sine of theta equals opposite over hypotenuse. Okay, I want just theta, so theta will be the inverse sine of 1.8 divided by 2.5. Right, so that'll get us our heading. Okay, so I got to point the boat 46 degrees west of north. Okay, it's quite a ways. I didn't draw that super accurate. That should actually be like way over here. Okay, so this angle is going to be 46 degrees. All right, well, I just calculated my heading. That was the first part of the question. And all I had to do was one trig calculation. Okay. Now they want to know how long will it take to get across. That means I need red V and the distance across, which they gave me in the question. Okay, so you can calculate red V with Pythagoras or with trig. Okay, I like using trig because I feel like it's a little more accurate. Okay, so I'm just going to go and get this side here. So I'm going to go cos of 46 times 2.5. Okay, so that side's 1.74. Now, I should be able to figure out how long it takes me to get across, right? T equals D over V, 50 meters divided by 1.74. Looks like 29 seconds to get across. Okay, so yeah, these questions have a little bit of vector stuff, but not nearly the amount we've been doing. But they do combine it with something else that we've done, and that's V equals D over T. Okay, the real challenge with both questions is reading the question carefully and understanding, am I going across or rowing across, and then setting it up to solve correctly. Okay? Questions on those two? Let's have you try that one. Did you know that a plane is just a boat that travels through the air? It's a true story. So boat questions, remember that was in air quotes, okay, can also mean plane questions, because a plane is an airborne boat. Okay, is this boat plane question easier than the two we just did? Because it doesn't ask you any of that, how far downstream or how long to get across kind of stuff. This one is just a very simple perpendicular vector question where we have the plane heading north, 225 kilometers per hour, and then there's a wind, okay, that is blowing 112 kilometers per hour east. That's really strong, okay? And we're looking, that'd be like a Chinook, okay? Blowing to the east, it's Chinook. Okay, and what's the final velocity of the plane, or what's the resultant velocity of the plane? Well, that would be this, and it says in reference to due north. So does it want this angle or this one? They're complementary, but only one is in reference to due north. Which one's in reference to due north? A or B? A. A is touching due north. Okay, sometimes both questions will do that. They'll say like with reference to the starting shore. Okay, well if they said reference to the starting shore, that would be this angle because that's touching the starting shore. Okay, if they say they don't care, then you can calculate either one, or maybe they just give you compass directions. Then it probably doesn't matter. But sometimes they'll say from this reference. Okay, just like this one is. All right, so we'll calculate theta here, and we'll calculate v here. So it's just Pythagorean theorem, right? So we'll have that v will equal the square root of 225 squared plus 112 squared. Okay, that'll give us our 251 kilometers per hour, and then we do our trigonometry. Okay, so tan to the minus 1 of 112 over 225. Okay, and that will give us our 26.5 degrees east of. Okay, everybody okay with that? They basically all break down to that. You're either putting them tail to head like this and finding the resultant, or the resultant is the straight across lines. It's one or the other, going across or rowing across. Okay. Anyone need that one up? Okay, so maybe just quickly write down this kind of quick and dirty reference for the two types of boat questions. Okay, where you've got a going across, that means you row into the current, okay, and your resultant is straight across. Okay, this line here is the width of the river, okay, and then the rowing across, just so you've got kind of a quick reference in your notes of the two types. Okay, so as we said before, the real difference here between rowing across and going across is which direction the resultant velocity points. Okay, in a going across question, the resultant points straight across because you're trying to end up at a point directly across from where you started. In a rowing across question, you've aimed for that point, but haven't corrected for the current, and so the resultant ends up pointing downstream at whatever angle. Depends on how fast you row and how fast the river is. Okay? Everybody follow there. Okay, so that's kind of the difference. You're going to get similar numbers, but you have to read the question and look for words like, like rowing across, or you want to end up straight across. Things like that can help to indicate what kind of question it is, so you can draw the diagram appropriately. Okay? All right, does anyone need that up anymore? That one I want. Okay, try this one. Okay, and I'm putting on there, this is a going across example. Okay, so you can have that in your head to start it with. So write it down. I'll give you a few minutes to try it. We'll go through it. So in this one, we've got that the boat is going across. Okay, so draw the river, and we know that our resultant then does this. It points this way. We don't know what it is, but we know that's the direction it points. Okay? Then it tells me that the person is capable of rowing at 3 meters per second, and it tells me the current is 1.2. So at least I know the current is about less than half of their rowing speed. So it gives me a way to at least get these lines drawn somewhat to scale. I know their rowing speed is more than twice as fast than the river is flowing. So when I draw the triangle, I can draw it that way. How did I know to draw the 3 meters per second as the hypotenuse pointing this way? Because it said they were going across. Okay? They can't be rowing across and going across at the same time. You don't go across by rowing across. Okay? Now, the other thing they want to know is, what's the heading? Okay? What direction are they pointing the boat while they row? So let's find that. That's part A. What direction are they rowing relative to the starting shore? Okay. Is that angle that I just drew in there relative to the starting shore? No. That would be this angle. Can I still calculate that one though?
Yeah.
Then I'll just go 90 minus and they'll have the one they want. Is that okay? Totally okay, right? I mean, either way will work. All right, so let's find that angle, okay? In this case, I have the opposite side and I have the hypotenuse. So I'm going to use sine for that. Sine to the minus 1 of 1.2 over 3.0. All right, so second sine, 1.2 divided by 3. Okay, so that angle that's inside my triangle is 23 degrees. The angle they want is 90 minus that. Actually, it's 23.5. Okay, so we'll say 24. So they're looking for the other angle, which would be 66 degrees from the starting shore. Okay, that would be the answer that I would give there. Okay, 66 degrees. Everybody all right with that? Jason's looking at me funny. Make sense? Okay. All right, so I've got the 66 degrees. Second part of the question. If the river's 20 meters wide, okay, so I got another piece of information here. This distance here is 20 meters. How long will it take them to get across? All right, so I'm looking for a time that goes with this distance. If I want a time that goes with this distance, I also need a speed, or a velocity rather, that goes with this distance. Which color of the triangle am I looking for? The red one. Okay? I want the red side because that's the side that points that direction. Okay? I can't use this one, it doesn't point straight across. So I've got to find that side. I'm just going to use trig. I already calculated this angle here, okay, and I'm just going to get the red line. Right? So I'm just going to go cos of, it was 23 degrees or something like that, or 24 degrees. Okay, so cos of 24 times 3 times the hypotenuse, and that'll give me that side. Okay? I'm going to keep that angle right there that I had. So cos of that number, okay, times 3. Okay, so they're actually moving across the river at 2.75 meters per second. Now that I know that number and this number, I can calculate time. Time equals d over v. 20 meters divided by 2.75 meters per second. All right. It's a small river, and it's only 20 meters wide, so that's not very wide. And it's only going to take them, at that speed, 7.3 seconds to get across. Okay? Questions on how that one worked? So I had to do Pythagoras. Actually, I didn't have to do Pythagoras at all on that one. Okay? I had to do a little bit of trig, a little bit of v equals d over t. Okay? And that's all you ever have to do in a book question. Pythagoras, trig, v equals d over t. Does anybody need that one up anymore? All right, I'm going to give you guys about a 4-minute break here. Just get in the classroom, get up, walk around, and then we'll look at another one. So, we got a rowing across example. Person is rowing straight across a 35-meter wide river. All right, so we'll draw the river. Okay, we'll draw that it is 35 meters across. Okay, and that they can row at 2.8 meters per second. Okay, so 2.8 meters per second. Current is flowing at 1.1 meters per second. Okay, what is the resultant velocity of the boat relative to the southern shore? Okay, I would say this is probably the southern shore, right? So our resultant then is going to be this, but I'm looking for that angle relative to the southern shore. Right? So, I mean, if I really wanted to do that, all I have to do is flip this triangle over and I can find that one directly, or I can find this one and go 90 minus. Either way will work. Okay, but first, let's get the magnitude of that velocity. So that's just Pythagorean theorem. 1.1 squared plus 2.8 squared. Okay, so exactly 3 meters per second. Okay, and we need the angle. So for me, all I'm going to do is go tan to the minus 1, but I'm just going to flip this triangle so that the 1.1 is adjacent and the 2.8 is opposite, and that'll get me the angle I'm looking for. Okay, so 69 degrees, and that would be north of east here. Okay, as my resultant velocity vector from the southern shore. Okay, everybody with me there? Okay, and that seems to fit, right? Like it's quite a big angle. Okay, this would be quite a small angle, so that's good. All right, how far downstream will they be when they reach the other side? All right, so I'm being asked to find this distance. Right? If I'm going to find that distance with that speed, then I need the time. Okay, I need to know how long it's going to take to get across, because the whole time I'm going across, I'm also going downstream. Okay, I have the distance across, I have the velocity across. So I'll use those two numbers, because they point the same way, to get the time. So T equals D over V, 35 divided by 2.8. All right, it's going to take 12.5 seconds to get across. Okay, well that 12.5 seconds also applies to going downstream, because I do that for just as long. Once I get to the other shore, both stop. Okay, so now I can go D equals V times T and go 1.1 times 12.5 seconds, and that'll tell me how far downstream I end up. So 13, well, we only have two significant digits here, so 14 meters downstream. Okay? There's not really any other tricks that can happen with a boat question. The biggest trick is identifying going across or rowing across, and that just involves reading the question here. Okay. Other than that, they're not too crazy. All right, any questions on those? Okay. Couple of things to talk about here. Obviously tomorrow you got your quiz. It's going to have some acceleration and some vector stuff on it. Okay, make sure you try those practice quizzes, right, so that you're ready for tomorrow's quiz. Make sure you have your formula sheet calculator, all that good stuff. And next week we'll probably start with like the map activity or something like that, maybe on Monday or Tuesday, just to kind of break it up so we're not just doing vector addition questions constantly. And then I would say probably by, not next week, but the week after, we'll be on to projectile motion, and that is the last thing in Unit 1. Okay, so I would expect a unit exam probably early the second week of October. Okay, so around Thanksgiving, which is kind of what I told you, okay, on the first day. So somewhere in there. All right. Since I have marked and entered your labs, and we have a little bit of time, why don't you grab your phones, okay, and bring your labs up, and we'll talk about this.